Edinburgh. The name itself conjures wistful visions of whiskey and mists.
This is a city of shifting light, changing skies, and sudden vistas. A city so beautiful it breaks the heart again and again.
At the hub of this modest-sized Scottish capital is its world-class university.
An engine of innovation that has driven Edinburgh's remarkable impact on the world of science and beyond. From physics
to botany to food. My name's Mirabai.
I'm Jasmina.
I'm Romeel.
And I'm Jarita.
And this is Science Tourist Edinburgh.
My love, she's but a lassie, oh my love, she's but a lassie. We'll let her stand a year or two. She'll no be hopsy sussy. Oh, I rue the day I sought her.
Nice to meet you.
You too. Welcome to the Royal Observatory.
Thank you. So you're John Peacock.
That's right, yes.
How long have you been working here?
I've been here over 30 years, so that's enough time to find out a thing or two.
I wanted to hear about one of the astronomers that worked here, Mary Brooke.
Yes, well, she left quite a legacy. Mary came here, in the late 1950s, and she was part of a husband and wife team. Okay, so her husband, Herman, was appointed director of the observatory. There was almost nothing here, in terms of people, that is. I mean, the old Victorian buildings are around, and by the time Herman retired in the early 1970s, that had gone up to over 100. So it was a great time for extra government investment in science. He was supposed to be also a university professor, building up the teaching of astronomy, and that was really what Mary did. She took that teaching of an undergraduate degree in astronomy that the university had never done before, and really set it up. They lived on site. This beautiful sandstone house was the director's personal residence.
Can we go see that?
Yeah, absolutely. Over here, the house, that's also unaltered, but the back would have just been, vegetable patches, lawns for the kids to play on, things like that. So you imagine growing up in a place like this, and all of this is where you come and play.
Right.
This was a family house, right? And Mary was involved deeply in the astronomy education. She would bring the students in for tea parties. So there was a kind of family atmosphere on the hill. Everybody felt themselves as one set of people all trying to do the same thing. And I think, a lot of academic institutions, sometimes they can be unpleasant places. People have feuds and they don't get on with each other. We do pretty well here, maintaining that friendly atmosphere. It's something we're all pretty proud of, and that's a good legacy to have.
Oh, wow, look at these views. Wow. Right, and this is, what did you call that one? Oh, I see, so it looks like a chair.
It looks like a little chair.
Yes, and then what's the cliff called?
My name is Mirabai Jasmina, and here we are in the Royal Botanic Gardens of Edinburgh, Scotland. Did you know that there are these things that happen in mountains? Glaciers happen, actually. So the glacier, it's on the mountain. It's not just any glacier, right? It's a permanent glacier. It's been there for forever. As the weather heats up, the glacier melts. And what else happens? Oh yeah, the glacier starts sliding down the mountain, and it takes all the dirt and rocks with it. So you get all these this bowl thing in the mountain. I don't think I'm right about that. Ugh. Humans. Disgusting. So these here are the plants that grow on the cliffs of alpine faces, like really, really steep, rocky cliffs. This one is a survivor of the Ice Age, which is pretty cool. Yeah. So these plants are meant to grow in very tough conditions. So not a lot of water, not a lot of shelter. The leaves, they're not terribly huge, and that's to conserve water. But they're also, big enough to catch as much sunlight as they can. This is the Butula utilis, or the Himalayan silver birch. As the name suggests, it has a lot of uses. This papery bark, before they had paper, people used this to write on. Also, it produces an acid that's very helpful in curing certain types of skin cancer and treating arthritis.
You can have a Maxwell moment.
The dude, man. The dude himself.
James Clerk Maxwell was arguably the most important scientist of the 19th century. His contributions we use in everyday life anytime you use a piece of electronics. So we're going to talk about this guy.
It's called Maxwell.
Maxwell. Yeah, that's right. No one really knew how electricity worked. No one really knew how magnetism worked. No one even thought that the two things had anything to do with each other. Until James Clerk Maxwell. Yes. And
Interesting thing about magnets.
Yeah.
It can magnetize things that aren't even magnets, such as nails.
James Clerk Maxwell
Oh, right, that guy.
was a guy who invented the theory of electromagnetism. He's got like 4 equations.
Wow.
Yeah.
Oh my god.
Newton only had like 3 laws. I mean, whatever.
Why does this and this, why can
Yeah.
they go like this?
Isn't that cool? Why is it that the nails keep doing that? It's really hard to get them stand up. Oh, darn it. Here, I'm going to try something else too. Whoa. What is it trying to follow?
The circle lines.
The circle lines. What do we call that?
The field.
The
Magnetic field.
That's what B is.
The magnetic field, the B, yeah, exactly. I'll show you what the Maxwell's Law is. B is the
Magnetic pole.
magnetic field. It's the field. It's the force field, kind of,
Oh, it's the...
of magnetism. So this is called the divergence operator. This is known as del. Del dot B.
Then we have
And the divergence operator measures what is the divergence in some region of space.
Yeah.
Maxwell's law says that the divergence of the magnetic field, anywhere you decide to draw that sphere, has to be 0. Anytime you have magnetic field going out of this region of space, you have to have the same amount coming back in. I got a question for you. Let's put all these magnets together.
Okay.
So this has 1 north pole, 1 south pole.
Sure, yeah.
Now how many north and south poles do you have?
There's 2 of each.
Now what would happen if I were to take one of these and split it down the middle? Would you get another
No.
2 north and south poles?
No. Yes.
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 Yeah, you would.
What?
Guess what? You've just learned one of Maxwell's laws.
Oh.
I'm going to draw this sphere. I'm going to draw it like this. I'm drawing my sphere that goes right through the middle of this sucker. I'm going to have it go out suddenly, and I'm going to say that's my sphere. Suddenly, a south pole has to appear inside that sphere. Like Jazzy said. So Maxwell's law is why every time you have a north pole, you can draw that sphere smaller and smaller and smaller. You will always have 1 north pole and 1 south pole.
Why does it go?
Like
Stop it.
it won't let us put 4 nails without one of them falling down. Like,
Whoa, cool.
this might be just these magnets.
No, there's a good reason for that. So you want me to show it to you with these magnets?
Yeah.
All right, cool. These things are trying their best to follow the magnetic field lines. Let's draw the field lines using these nails. The magnetic field line actually gets transmitted through these iron nails. And so this configuration is actually pretty stable. This is an example of Maxwell's laws.
The ingredients I'll be using today is mushrooms, carrots, onions. Secret addiction. Oh, we can get a whole wedge. Mixed nuts, a dash of soy sauce, a dash of lemon juice, ground almonds, roulade beans, lentils, sunflower oil, butter, finely ground corn. Can't stand this section anymore. Stop. Just jump. Play with that. Ooh, can we eat those?
Oh wow, these are really, they're much better than because if you can get up there.
I know, there's a bunch of them.
Mirabai, I did a little research on these names and I couldn't find anything on the Dionysias, which are the little ones that are fuzzies.
I like these plants because they're hardy and they grow in places that other plants don't. Dionysia and Daphne are both cushion plants. Dionysia, which is a type of cliff-growing shrub that grows in tufa limestone. It's in little dirt pockets in the limestone. Daphne more resembles a shrub. It's kind of more spread out. It's got bigger leaves. They're used to harsh environments, so they have small leaves and they're close together to withstand temperatures of up to 40 degrees Celsius and negative 10 degrees Celsius at night. That's really hot, really cold. Mrs. Poeple. They're called Mrs. Poeple. They also have a scientific name that I've forgotten at the moment. So what's interesting about Mrs. Poeple, not only do they make excellent additions to your garden, but they can also be eaten. You can eat the flowers, you can eat the fruit.
Tell us about it.
It's sweet. It's got this kind of weird taste. It's kind of like a mix between a grape and a flower, and now it's stinging my tongue.
There you go.
Thank you, Mother. Whip circle.
Whip circle? Oh my God. This is amazing. And the view is unbelievable.
It's one of the best views in the world, I think. Certainly one of the best astronomy views. A place to work like this where you can just come out and take in this view if you're feeling a bit jaded. It's a real privilege.
So the telescope is in this dome.
That's right. And this big heap of copper keeps the elements off. That's the plan. Neither of the telescopes have done anything since the Second World War. We have a teaching telescope, but it's much smaller.
Where is it?
Oh, it's just over there. In fact, you can't quite see it.
Where the other dome
It's a little silver dome just behind the big copper one.
And so I hear you have a bunch of rare books as well.
Well, that's right. That's the Crawford collection. It's a great story. That's why we're here. This observatory was built in 1894, and that took a lot of government money, and they were only willing to spend that because they were donated this collection of about 15,000 books by the Earl of Crawford. It looked like Scottish astronomy was going to be closed down because it was too expensive, and he bribed the government not to do that. It's really inspiring to look at that stuff and think, this is 500 years old, and you know, the astronomy that we do today is just built another layer on that foundation.
That's fantastic. I think it's the first case that I've heard of an observatory being saved due to a library.
Due to books, yeah, that's right. He wanted there to be a national observatory. He was concerned that Scotland should have its own world-class telescopes and facilities, and the only way to make that bring about was to take some of his collection. He also gave the government quite a few of his own telescopes as well, but it was the books that sealed the deal, as it were.
Tell me about Open Day.
Well, that's the busiest day of the year here. It's part of an exercise that goes on all over the city called Open Doors Day. All sorts of places that the public would never get into normally have a tradition of just putting on tours, and we do the same. It's the only time of the year the average members of the public can come here and experience this great view. And we show them exhibits about the work, and so everybody has a great time.
Do they get to see a big telescope?
Sometimes we do have a solar telescope, just a little one. It projects an image of the sun, and you can see sunspots and so on, and that's and people like that if the weather's good, which of course in Scotland it always is.
Thank you.
One of the people who's you may have heard of before is James Watt. Every time you put in a light bulb, you think, should I put in a 40-watt light bulb or a 60-watt light bulb, maybe a 100-watt light bulb? That unit of power is named after this guy. James Watt was Scottish. He worked here in Edinburgh. And he's probably most famous because he made an advance on the steam machine that was so revolutionary that it enabled all kinds of things, steamships, locomotives. Really, it enabled the entire industrial revolution. It was the first time humans were able to use power generated from something that was not natural to run machinery. Steam engine uses one of the most basic and remarkable principles of physics, and that is, very simply put, nature hates a vacuum. So it all comes back to this little object right here. That's the cylinder. We have a source of water, we have some coal that heats it up, burn the coal, make some steam, put it into that cylinder. The steam has pressure. The steam is filling up that cylinder. If you take steam and spray some water into it, it condenses onto the water droplets. And all that steam that was filling that cylinder collapses down as water to the bottom of the cylinder, leaving a vacuum. So the only way the nature can fill that vacuum is to push that cylinder down. That cylinder goes down, this lever comes up on the other side, and the wheel starts turning. That's your steam engine. But that was all discovered actually 50, 60 years before James Watt. So what did James Watt do that was so special? Well, here was the problem with what I described. So this steam cylinder is doing this every cycle. It's expanding when it gets hot, it's contracting when it gets cold. Why is it a problem? First of all, you're wasting a heck of a lot of energy heating up and cooling down this cylinder that has nothing to do with what you actually want to run. Second of all, it's a huge stress on that metal. That cylinder gives out, starts cracking, and as soon as it cracks, no vacuum, no power. So people had built steam engines before James Watt, but they had never really been very successful. So James Watt was walking in the meadows one day in Glasgow when this idea came to him, and that was in 1765. And he thought, watching the wind blow the leaves across the meadow, he visualized steam as an elastic object. And he realized that if he had a separate condenser unit which was connected to the cylinder, that the steam would automatically flow to the condenser. And there he would be able to cool it and therefore never have to cool down the cylinder itself. If this were a real steam engine, what would be happening is that steam would be coming into the cylinder, it would be piped through to the condenser, the steam would be cooled down in the condenser, creating a vacuum that pulls the cylinder down. So you're actually using suction, the fact that nature hates a vacuum, to power machinery. It's pretty incredible, huh? James Watt was a very bright guy, wasn't a great entrepreneur, but he had a great idea. And so he had a friend named Matthew Boulton. He actually knew how to make money with James Watt's idea. So he started an amazing ad campaign that said, look, we've got this machine that is way more efficient than anything you've ever seen before. And here's how it works. It took many years before Boulton and Watt were able to successfully market their new invention. But by the late 18th century, the name Boulton and Watt was synonymous with steam power. In fact, so much so that by the late 1800s, in 1882, the British Association for the Advancement of Science declared that the unit of power in the standard unit system of kilogram, meters, and seconds would be called the watt. A 1 watt, would represent 1 kilogram meter squared per second cubed. In other words, energy per unit time. That's what power is. And so because of this, we now refer to units of power as watts.
Welcome to my kitchen.
What is the plan for the vegetarian haggis?
It's easy to make. What we first need to do is to slice and cook these vegetables. And as those are slowly simmering, we're supposed to make the soup. Let's start with the cooking. I like to put the oil before the pot heats, so you know when the pot is warm. This is almost done. Hope you washed your hands. Here I'll be cutting my almonds and hazelnuts for a bit more flavoring. And over there, I am cooking my carrots, mushrooms, and onions. We're going to be using 74 grams of red lentils. This is my vegetable stock usage for today. I'm going to slowly stir this in with a tad bit of water. You add your 74 grams of uncooked red lentils. Making sure the vegetable stock gets everywhere, so it really flavors the lentils. What? I'm fine. I'm impatient. Let it simmer. I'm going to be adding the beans, the almonds, and the hazelnuts, and then our lovely roasted vegetables. Add a bit of salt and stir it together. We have to gently fry this, so let's take our oil, soy sauce, the lemon, ground almonds, oats, brown gravy mix, our corn bits, I don't know what I did, but I made some haggis dough. But I'm gonna crumble it into this bake-friendly tray. Now, after crumbling this, take some of your vegetarian mix, spread it, take your dough, or whatever yours looks like, because it gotta be better than mine. It's all gonna taste the same, right? When it comes out, that should finish it off. Now, you let it sit for 20 minutes, and then you bake it for another 3. Dance. Hey, 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 hey. I love it. This is my finished product of my vegetarian haggis. It may not look the same, but it probably tastes the same. Delicious.
O your ma, we gallus block nae mer. O your ma, we gallus block nae mer. Wi your bell blue strides and your bonnet to the side. O your ma, we gallus block nae mer. I went down by the sweetie work, my heart began to beat. Seeing all the factory lasses coming down the street, with their flashy dashy petticoats, their flashy dashy shawls, 5 and 10 are gutty boots, all wear big gallus malls. Oh, your ma, wee gallus blubney mare. Oh, your ma, wee gallus blubney mare. Wear your bell blue strides and your bonnet to the side. Oh, your ma, wee gallus blubney mare.